Hello students, in last lecture we have seen that how switch debouncing works and how NAND gate is used for the key debouncing circuit. In today's lecture we are going to discuss about the designing of code converter using K-map, which K-map is the thing which we have studied in detail in the first year only. The revision of K-map which we are going to study today. The Karnaugh map, also known as Wein's diagram, KV map or K-map, it is a method to simplify Boolean algebraic expression. The Karnaugh map was invented in 1952 by Edward Veach. So this is the scientist whose name is Edward W. Veach, and he invented the method to simplify the Boolean algebraic expressions. It was further developed in 1953 by the Mauritian Karnaugh. So there is another scientist who made some changes into the method which is developed by the Edward Witch, and later on it is popularly called as a K-map. He invented that method in a he was a physicist at the Bell Labs to help to simplify digital logic circuits. In a K-map, the Boolean variables are transferred either from truth table or a Boolean expression. So in K-map, we already know that in how to fill the K-map, either we should know the truth table or we should know Boolean expression, or and ordered according to the principles of the gray code, in which only one variable changes in between the squares. So we know how to put the values into the K-map. For simplification of Boolean expression, one can use Boolean algebra laws, right? For the simplification, we can always use the laws of Boolean algebra, but Boolean algebra methods has had some disadvantages. Which are those disadvantages? It is difficult to apply these laws when the number of variables are large. So with the help of Boolean laws of Boolean algebra, we can simplify the equation which contains very less number of variables. If the equation contains large number of variables, in that case it is quite difficult to simplify the given algebraic expression. As the Boolean algebra laws are used in a every step, and there are 22 laws in all. So one have to remember all these laws and has to apply them at a correct place. So this is what is the again biggest disadvantage which we faces while using the Boolean laws. So overall there are 22 Boolean algebraic laws, and we have to use that particular law at a particular correct position, right? So this is one of the biggest disadvantage to remembering the 22 laws. That is why K-map is one of the easy method. Use of large number of laws increases the chances of error. So there are some errors which can be there with the help if we are solving the equation with the help of Boolean laws. All the time applications of these laws does not lead to the simplest possible expression. So even after solving so many complicated equations with the help of laws of Boolean algebra, there are low chances or the very less chances in which we can lead to the simplest possible expression. So that is why Karnaug's map provide the solution to all these problems, and it is graphical representation of a Boolean expression. So whatever the Boolean expressions we are going to have, Karnaug's maps or the K map is it's just the graphical representation of a Boolean expression. It provides the easiest way to produce a simple Boolean expression within a minimum chances of error. So the chances of error in a Boolean expression which we are solving with the help of K-map are very low. So here we are going to study the designing of code converters with the help of K-map. So code converters are what? Converting a code from one format to the another format, and we have to design those code converters with the help of K-map. Now we'll see what is code converter first. A code converter is a combinational circuit. So we all know what is combinational circuit. A logic circuit whose output is dependent on present state input only, and that translates the input code, which is input code, into the corresponding new code word. So basically, the logic circuit which converts the input code, whatever input we are going to provide it to you, it will convert that code into the corresponding or required or desirable new code word. So this is what is the basic function of code converter. There are different types of code converters. They are classified into two types basically. The code converters which converts more general code into the desired code are known as encoder. So the code converters which converts more general code into desired code, those are called as encoder. And the code converters which converts this code back into the general are called as decoder. So basically, code converters are broadly classified into the two different types. One of them is encoder and second one is decoder. So encoder is what? It is just a code converter which converts general code into the desired code. And the decoder is a circuit which converts desired code back into the general code. The converter which converts decimal code to BCD. So the converter which is going to convert a decimal code into its equivalent BCD format, that is binary coded format, it is known as encoder. Okay, or decimal to BCD encoder. You can simply name it as decimal to BCD encoder. Whereas the code converter which converts BCD code to the 7-segment code. Okay, the code converters which is going to convert binary coded decimal code into the 7-segment code, it is known as decoder. So in the article 2.7.3, we will study how to design BCD to 7-segment code converter. Here, in this, we have to design a BCD, that is binary coded decimal to 7-segment code converter with the help of K-map. So we can have a look at this. This is your next point, which is BCD to 7-segment decoder. A digital display that consists of a 7 LED segment is commonly used to display the digital decimal numbers in a digital system. So you might have seen at various shops, there are some displays, digital displays, which are used to display the digital numbers or the decimal numbers, you can say, right? And those are made up of LED segments. Different LED segments are connected together to form such displays, and those displays are called as 7-segment display. Why? Because there are 7 LED segments used in each display. That is why it is called as a 7-segment display. Actually, each segment is nothing but a LED segment, right? Their connections leads are bought out, and by applying a forward voltage to the segment, it to be turned on. We can display any number between 0 to 9. With the help of a single display, we can display digits from 0 to 9. Now, how to display? Each LED segment will have its output wire, and by providing a forward voltage to the LED segment, we can just turn it on. And by removing the forward voltage, we can turn that LED segment off. So this is how 7-segment display works. The following figure shows you the 7-segment display, correct? So 2.12a, this figure that will show you the 7-segment display. So this is how 7-segment display looks like. And the figure 2.12b shows the display of numbers. So with the help of these display, if I want to represent 1, if I want to represent 2, if I want to represent 3, any number in between 0 to 9, we can select the number of LED segments which should be turned on to display that particular digit. So for an example, see here, if we want to display digit 2, okay, we'll see this diagram in which the labeling is there: A, B, C, D, E, F, and G. Okay, we will consider this diagram, and in this diagram, if I want to display digit 2, now which LED segment should be turned on? So as we can see here, to display 2, A segment should be on, B segment should be on, G segment should be on, E segment should be on, and D segment should be on. With the help of A, B, G, D, E, these LED segments, I can display let a digit 2, right? So as you can see here, the segments A, B, D, E, and G should be turned on, and all the other segments should be off. So this is very important. While displaying digit 2, I want to turn on segments A, B, G, E, and D. But at the same time, segment F and segment C should be turned off. Then and then only I'll be able to display digit 2. We can display any number from 0 to 9 by making on various combinations of the segment as shown in the below table below, right? So with the help of these 7 segments, I can display any digit from 0 to 9. How to do that, or how to turn on the LED segment, proper LED segment, which LED segment should be on to display which digit, we are going to study in the next table. So as we can see here, to display 0, okay, to display 0 on this display, which LED segment should I turn on? That is A, B, C, D, E, F. All the segments except G I should turn on. So as you can see here, all the segments A, B, C, D, E, F, all of them are on except G. G is off. If I put G off and if I turn on other remaining remaining segments, then I will be able to display digit 0. Likewise, if I want to represent digit 1 on this 7 segment display, so which segments I should turn on? So I can simply turn on B and C, and I'll keep others turn off. So as you can see here, C and B, only 2 segments are on to represent 1, others are totally off. Correct? To represent the digit 3, which segments I should turn on? So as we can see in the diagram, segment A, segment B, segment G, segment C, and segment D. So these 5 displays or the 5 segments I should turn on, and I should keep F and E segment off. Then in that case, I will be able to display digit 3 on a display. Right? Likewise, you can display any digit from 0 to 9 with the help of turning on and off the LED segments. For which segment should be turned on and which segment should be turned off are listed in this table. Now, moving to the next, there are two basic types of 7 segment display. Okay, if we are studying a 7 segment decoder, we have to know that there are two basic types of 7 segment display. One of them is common anode type and another one is your common cathode type. So we know what is anode and cathode. Anode is the positive terminal of diode and cathode is the negative terminal of diode. Common anode indicates that, so we already know we have 7 segments, that is 7 LEDs we are going to have, and all the anodes of each and every LED should be get common. Common anode, this indicates anode of each and every LED is connected together, and that connection is attached to the plus VCC. Common anode is nothing but combining all the anodes of all the diodes together and connecting that connection to the plus VCC. See, in common anode type, anodes of all the segments are connected together. And in common cathode type, cathodes of all the segments are connected together. So this is how common anode and common cathode are differentiated. So we can see the diagram. Diagram figure 2.13 shows the common anode LED display. So as we can see in this diagram, anode of each LED is connected together. Okay, at this point, each and every anode is connected, and that connection goes to the plus VCC. The cathode of each and every diode is connected to the LED, right? So if I want to turn on LED A, I will provide a negative voltage at this point. Right, as we are getting positive supply to the anode, I should provide negative supply to the cathode. In that case only the LED will glow. This is external current limiting resistor. These resistors are used for the current limiting. Next one is your figure 2.13 shows common anode LED display, in which it is simply state that cathode of each and every LED is connected together and the connection goes to the plus VCC. Again, anode is free and we are going to provide ground to the segment or to the anode terminal, sorry, where we want to turn on the LED. Again, there are external current limiting resistors are placed in between. Now, the next thing is use of decoder for the driving the 7 segment display. Now, there is one more thing. We cannot connect these pins to the supply, right? So we cannot connect these things directly to the supply because of the, if we do that, if we connect direct connection in between, so there will be a huge chance of the damaging the entire circuit. So that is why we are attaching, or we are adding a driver circuit in between. So use of decoder for the driving 7-segment display. So BCD to 7-segment decoder generates the 7-segment code, right? So the encoder which decoder which we are having, that will convert a BCD code into the 7-segment code, and it will display that on a in the form of a digit. Now we will see how to connect the connections. This is your BCD to 7-segment decoder, or you can simply say it is a driver. Okay, BCD are the numbers which are 4-bit BCD inputs we are going to provide here, A, B, C, D. This is your 4-bit BCD input. Now this BCD to 7-segment decoder will do what? It will convert that 4-bit BCD input into the 7-segment input, 7-segment output. Right? So these 4 bits are converted into the 7 outputs, A, B, C, D, E, F, and G. Now, this is the common anode connection. As we can see in the diagram, the connection which we are seeing is the common anode connection, as the anode of each and every LED is connected together and the connection goes to the plus VCC. Right? And cathode is connected to the BCD to 7-segment decoder. Likewise, we can achieve the decoder driving the common anode display. Again, these are these resistors are nothing but current limiting resistors. So it is a resistor, RESISTER. The decoder accepts the 4-bit BCD code. As I told you earlier, this decoder will accept the 4-bit BCD input and converts it into the 7-segment code. This decoder is going to accept this 4-bit input and convert that 4-bit input to the 7-segment code, which is suitable for the 7-segment display and drives the display. Table 2.3 gives the truth table of BCD to 7-segment decoder. So the table which is given below, that will give the entire description of BCD to 7-segment decoder. Here A, B, C, D are the inputs. So we know A, B, C, D are nothing but input to the system, right? A, B, C, D are the inputs, are the BCD codes for the numerals 0 through 9. Let us assume that the type of display is common anode. So we have to consider, if it is a common anode, then we have to put a 0 voltage to the pin whose LED we want to turn on, right? If we provide 0 voltage at this point and there is a plus VCC connected to this point, then in that case, this first LED will glow, right? Because to turn on the LED, we will need a positive supply to the anode, and there should be a negative or ground supply to the cathode. In that case only the LED will glow. So to do that, or to achieve the turning on of the LED segment in case of common anode display, we have to provide 0 voltage to the anode terminal. So the assumption is very important. Either we are considering common anode configuration or common cathode configuration. So here we are assuming that the type of display is common anode type. Hence the output of the converter should be 0. As I told you here, the output of this converter should be 0, so that 0 voltage or low voltage will be applicable to the cathode of the diode, and high voltage is already providing to the anode side. So output of converter should be 0 if a particular display segment is to be turned on. So if I want to turn on a display, in that case only we have to provide 0, right? If I want to turn on first LED, I will apply 0 to the first LED only. If I want to turn on fourth LED, then I will apply, so there should be a 0 voltage to the fourth LED only. If I want to turn off second and third, so in that case the voltage will be 1 volt here, or the logic 1 volt here, right? So with the help of this information, we can simply fill this truth table, right? This is your decimal digits from 0 to 9, which you can display on the 7-segment display. This is nothing but your BCD input, that is A, B, C, D. BCD input you are going to have, and this is nothing but the output, 7 segment output, A, B, C, D, E, F, G. Correct. So if I provide 0, 0, 0, 0 as an input, so in that case, what will happen? So if I provide 0, 0, 0, 0 to the input, so what will happen? Only a G segment will be turned on and remaining will be turned off. Now here we are providing 0 voltage to the all segments. What does that indicate? The segments which are getting 0 volt will be turned on, and the segment which is getting 1 volt, that segment will get turned off. Why? Because I already explained the reason. If we want to turn on the LED, we have to provide 0 volt in case of common anode segment or common anode configuration. Likewise, if I want to represent 1, I have to provide 0 0 to the segment B and C. What does that indicate? Only segment B and C will be turned on and the remaining segments will be turned off. Correct? Likewise, we have to write the outputs for the each and every digit from 0 to 9. So this table will give you the detailed information how to represent or how to provide the inputs in the form of BCD, and which is the output we are going to get for the common anode type 7-segment decoder. Moving further, once we achieve this truth table, we have to go for the K-map implementation. So we will cover this K-map implementation in the next lecture. Thank you.